Hi, in this project we have proposed end-to-end IoT framework. We are a group of four named Jayant, Jeevant, Vishnu, and Tarun. Can you jump to the first slide? So this is the first slide. It's the introduction. So the Internet of Things stands a technological revolution that has transformed the way we communicate and exchange information. Also leverage the sensor data to enhance our quality of life. So by connecting physical devices, vehicles, appliances, and other objects through internet, IoT has ushered in a new era of connectivity and automation. This has not only simplified and streamlined automotive and repetitive tasks, but has also opened up a vast opportunities across various industries like IT. And if you see, the IoT ecosystem is a dynamic and multi-phased landscape encompassing a diverse range of devices, technologies, and systems that work in to enable efficient data exchange and communication. So the intermediate between these interconnected components creates a network of smart devices capable of gathering and which can also analyze and sharing the data autonomously. So as a result, IoT has found appliances in smart homes, healthcare, transportation, agriculture, and industrial processes, also in the many other fields. So it's like a revolutionizing in various fields. So can you jump to the first slide? So in this presentation, we will explore the transformative impact of IoT on our daily lives and dive into the complexity of IoT ecosystem. Also, by understanding the challenges and the opportunities that arises with IoT's rapid growth, we can unlock the full potential of this groundbreaking technology and make the way for a more connected, efficient, and secure the future. So, so this is the second slide, which discusses about the problem statement. So the rapid growth of IoT has brought about transformative opportunities, but it has also given rise to significant challenges in the commercial use. Few of the key issues is the like one can be considered as systems specifically designed to address efficiency and security concerns, while also ensuring the optimal operating system support. As a consequence, organizations are facing a series of challenges that has seamless adoption and utilization of IoT technology in various industries, like for an example, inefficient device management. So the IoT devices in commercial settings has made the manual device management an inefficient task. Without a centralized management system, organizations struggle to configure, monitor, and control their numerous connected devices, which are interconnected might be. And the second will be the lack of scalability. So as the number of IoT devices in the commercial applications continues to grow, it becomes more crucial to have systems capable of scaling to meet the demands of larger network. So failing to plan for the scalability can result in data processing errors and also the increased response times and few challenges in managing the expanding connected devices. So privacy and security concerns uh, can also be considered as one, because the large amount of data gathered and transmitted by IoT devices raises significantly, which might have privacy and security concerns. So the robust security measures needs to be followed by different industries, and the resource utilization can also be considered. Many IoT devices are resource constrained, which are having limited processing power, memory, and battery life. So inefficient resource utilization, like it may have some limitations like device failure, reduced battery life, and low performance. So coming to the third slide, it's the objective of the study, which has been detailedly discussed in the project document. But long story short, I can explain it as it's a comprehensive framework to address the main challenges in the field of IoT and improve the system efficiency and security, which can significantly improve the adoption and utilization of IoT technology in various industries. Mainly, this framework must be keep a focus on three concepts, which are like optimal operating system support, efficient device management, and enhanced resource utilization. So by addressing these all three aspects, organizations can overcome the existing challenges and unlock the full potential of the IoT for the commercial use. So if we discuss about the optimal operating systems, we can say it as, so if you want to improve the system efficiency and security, selecting the appropriate OS for IoT devices is very crucial. So the operating systems must be very lightweight, responsive, and tailored to meet the specific requirements of the IoT applications. It should also support the security features to protect against the cyber threats and unauthorized access. And real-time operating systems, it's well suited for IoT devices that which require immediate responses. So it can give the timely responses and timely execution of the tasks which are required. And third one will be Linux-based OS. It's a unique platform with extensive community support and wide range of tools, so we can configure as per the requirement, which will be suited by the operating system. And regular firmware updates, like we can implement the secure boot mechanisms, and over the firmware updates ensures that IoT devices and protected against the viruses which might be encoding daily life. So the third slide. So this one will be the literature review in the IoT device management. So the current centralized approach to managing IoT devices can become highly inefficient, especially as the number of devices and the complexity of networks increase. Heterogeneous modules and dynamic connections pose significant challenges in scaling and optimizing the resources. To address these inefficiencies and provide an effective solution, the proposed framework leverages a distributed three-dimensional social network model to represent the interactions between the services and IoT devices. So to discuss in detail, as I said earlier about the distributed three-dimensional social network model, it's a new unique approach to represent the relationships and interactions between the various entities in the IoT ecosystem, which has concepts like social networks, services, users as nodes in the network. Coming to the nodes, we have like two types of nodes, device nodes and service nodes. IoT devices such as sensors, actuators, and smart devices are represented as nodes in the three-dimensional social network. So each device node holds information about its capabilities, status, and context. The second one will be the service node. Services that interact with IoT devices such as cloud services, analytics platforms, and application servers are also represented as nodes in the network. The service node provides functionalities for data processing, storage, and analytics. User nodes, users whether the which can be considered as whether the individuals or organizations which interact with IoT ecosystem are represented as nodes. These user nodes may access data, control devices, or get the insights from the IoT devices about the performance and what's going on. And we also have like decentralized communication and collaboration. And this is also a three-dimensional social network model. So long story short, to explain, we have three concepts in this. It's device-to-device communications. The IoT devices can communicate directly with each other when required and exchange the data if required. The second one will be device-to-service communication. IoT devices can interact with specific servers directly based on their capabilities and requirements. For example, like a sensor can send data directly to a cloud-based analytics service for real-time processing and insights. And last will be user to device and user to service communications. So few users can interact directly with IoT devices and services, which allows them to control devices, receive notifications, or access data insights as needed. And coming to the flexibility and adaptability functions of this offers flexibility and adaptability to the dynamic nature of IoT networks as devices join or leave the network. The model can easily adapt to these changes seamlessly without any interruption, like because it has few features like dynamic network topology, which can dynamically adjust as devices or services which can be added or removed at any time. So which ensures like continuous connectivity without any disruption in between. Self-organization. This model also enables self-organization among the devices and servers, allowing them to form ad hoc connections based on the context and requirements. Scalability. The distributed nature of this model enables like horizontal scalability, as the network can grow and adapt without becoming a interruption in large scale IoT deployments. So, as discussed, by adopting this distributed three-dimensional social network model, the proposed framework aims to overcome the inefficiencies of the IoT device management. The decentralized communication and collaboration approach enable more direct interaction between the devices, service, and users, which in turn reduces the latency and improving the system efficiency. Yeah, it's finally it's like this innovative framework has the potential to improve the IoT management and drive the evolution of more efficient and effective IoT ecosystems. So the next slides will be explained by one of my teammates.
Thank you, Jen. That was a wonderful introduction. Now we'll look into the literature review edge computing. Nowadays, edge computing has become popular in industry and academia. It can potentially improve the performance of IoT systems by reducing the data processing time, improving communication, and optimizing usage. The proposed framework utilizes various edge computing technologies, including for computing, mobile edge computing, which is called MEC, and cloudlets. Whereas when we look into the one of the slide, it is said that a comprehensive overview of edge computing's latest developments, categorizing into cloudlets, MEC, and fog, focusing on security, data analytics, and real-time applications. This study identifies research challenges and solutions, offering valuable guidance for future researchers. Whereas 5G integration with edge computing enhances performance by reducing latency and improving throughput. Whereas it is also mentioned in one of the article that it discusses about 5G edge computing types and the requirements for successful deployment in cellular networks, addressing fog-based hybrid and MEC solutions. Now let us move on to the next slide, which discusses about IoT security and privacy. IoT security and privacy are significant concerns in the complex IoT ecosystems. And there are several challenges like there is a proposed risk assessment framework and reveal IoT vulnerability, which urges to the adoption of protective measures. Due to this complexity of the IoT ecosystem, privacy and security are becoming increasing important factors. A survey by one of the authors revealed that there are various challenges facing the system security and privacy, emphasizing the need for enhanced measures to protect it. So this proposed framework includes security and privacy features such as vulnerability analysis and risk management techniques to protect confidentiality and integrity of data. Now we'll move on to the next slide. This slide is about high-level architecture, where IoT resource management is crucial for efficient system performance and energy consumption, whereas it analyzes resource allocation techniques for IoT networks, including power-aware, context-aware, and SLA-aware techniques, providing insights into future research directions. This proposed framework includes various key components such as devices, resources, and communications. The high-level architecture of the framework includes sensors, actuators, network technologies, and the access networks. So efficient communication is vital for IoT applications. One of the author mentioned that reviewing pricing models and economic analysis for IoT wireless communication, exploring their application in adaptive protocols and algorithms for wireless sensor networks and crowd sensing. Um, so next slide, it is about the device management. The device management component of the framework includes device configuration, device monitoring, device authentication, and device firmware updates. It prevents unauthorized device access or data leakage by exposing insecure networks, protocols using machine learning models. So overall, these studies emphasize the importance of addressing resource management, security, privacy, and communication challenges, which unlocks the full potential of edge computing and IoT in shaping for future technologies. So further presentation will be carried by Tarun Teja.
Hello, Professor. This is Tarun. We'll know more about the framework proposal that is given by our article. So, a literature review on Internet of Things ecosystem reveals challenges in device management, security, privacy, and resource allocation. To address these, a proposed end-to-end framework consists of certain key components. Connecting virtual and physical worlds through sensors, actuators, and network technologies like WSN and 5G, 4G. Access networks bridge sensors to powerful domains like storage and computing. So let us come back to the framework proposal components, security and privacy. In order to protect the data collected and stored in the framework by the IoT devices, various security measures are implemented. These measures include authentication via biometrics or facial recognitions, monitoring, and certain authorization techniques. The framework also includes a risk management framework that can aid in design and implementation of IoT systems. Moving on, another component of framework proposal is resource management. The resource management component of the framework focuses on efficiently allocating and managing resources in IoT environment, comprising memory, network bandwidth, and device drivers. The goal is to achieve the highest resource utilization and energy efficiency possible. So this allocation will be in the areas of memory, network bandwidth, and virtualizing the computers necessary for doing this, doing the computation power. And addressing resource optimization and energy consumption using power-aware, QoS-aware, and context-aware techniques are useful in successful resource management techniques. And moving on to other component of framework proposal, that is communications. The communication component of the framework aims to enhance and streamline communication and connectivity between IoT devices, gateways, and the cloud. Its primary focus is to address the challenges related to data transmission, network protocols, and connectivity within the complex and diverse ecosystem. It ensures reliable communication with protocols such as MQTT, HTTP, and QoAP, and data processing to IoT gateways. The components include IoT gateway, reliable transmission, and network connectivity to achieve the seamless communication between IoT devices and also from IoT to the cloud offsite centers. And moving on to the next slide. The proposed framework for an end-to-end efficient and secure system with OS support is recommended to establish a highly efficient and secure system with the support of OS. The framework's performance must also be assessed to meet the needs of IoT applications. And the next presentation will be carried out by Vishnu Mahesh.
Hello, Professor. This is Vishnu Mahesh. I'm going to carry forward the next slide. Okay. I'm here to continue with the justification and an evolution of our project. The study proposes an end-to-end framework from which, for an efficient and secure network of our Internet of Things system with OS support, and it prioritizes the connectivity, security, and privacy of the objects, offering significant advantages over current approaches. The framework focuses on social network-based device management, edge computing to reduce latency, and robust security measures like authentication and monitoring to safeguard the data which is connected to the devices. And here, with the next slide, we'll go to the conclusion. The study analyzes the different aspects of the Internet of Things and provides valuable insights into the developments and challenges in these areas, where the proposed end-to-end framework helps improve the system efficiency and security through OS support. The impact included enhanced system efficiency, reduced latency, heightened security measures, and optimized resource utilization, where the scalability, performance, security, and feasibility are critical for the framework success in handling increasing connected devices and data volumes, performance assessment, and addressing challenges in device management, security, communications, and resource resource utilization enhance IoT application development, where the future research options, which provides us the future research should give significant importance to the several critical aspects. One key area that requires utmost attention is the exploration of advancements in edge computing and their effective integration with the Internet of Things, where the proposed framework has the potential to revolutionize the IoT, where by improving their efficiency, reducing their latency, bolstering security, and optimizing source utilization, which accelerating the IoT device technology adoption. So the future research should explore advancements in edge computing, seamless device collaboration, and security through encryption protocols, so that to address the privacy and security concerns. So the impact of framework on the ethical considerations, where the impact includes enhanced system efficiency, reduced latency, as we discussed. So these advancements pave the way for innovation and expedite the widespread adoption of the IoT technology, where the system requires attention not only to the technical aspects, but also the ethical concerns that must be addressed to protect the user's privacy. So the framework raises questions about scalability, efficiency, and ethics to protect user privacy, and a comprehensive solution is proposed to overcome challenges and positively impact the IoT systems, inspiring further research in the field by refining IoT technology and fostering the innovation. The framework proposes a promising future for the connected systems, where the implications of the proposed solution and potential of the framework, as we discussed just now, the positive impact, contributions, and implications of this proposed solution could significantly influence IoT systems developed and foster further research in the field. So the proposed framework has the potential, as we discussed, to revolutionize and by enhancing system efficiency, reducing latency. These advancements can foster innovation and expedite widespread adoption of IoT technology. So by this, we conclude our project. Thank you. Have a great day, Professor.
Thank you, Professor. Thank you, guys.